Welcome to this video on the topic of trigonometry. In this video, we're going to have a look at how we can calculate unknown angles within right-angled triangles. Now, unknown angles within right-angled triangles may be calculated when we know at least two side lengths. To do this, we use the inverse trigonometric functions. These are inverse sine, inverse cosine, and inverse tangent. These functions are also sometimes called the arc sine, the arc cosine, and the arc tangent. Using these inverse functions, we're able to deduce the unknown angles within a triangle. Moving on to some examples. In this triangle we have two known quantities and one unknown. The two known are the side lengths and the unknown is this angle of interest here. To solve for the angle of interest, the first thing we do is we label all of the features within the triangle. Now that they're labelled, I'm going to list all the features and then pick the ratio that I'll be able to use to deduce the unknown. Based on what I can see, I have an angle of interest theta and I have a known opposite and a known adjacent. That's going to tell me that I'm going to use TOA. Writing out the tangent ratio, I then sub in my values. It's at this point where I hit the roadblock. I have an unknown angle but a known ratio. What I need to do is I need to employ the inverse tangent ratio here, or the inverse tangent function. So I'm going to write inverse tangent just to show that I'm about to employ that ratio. What this effectively looks like is as shown over here. So we have a tan t inside the inverse tan. The inverse tan of the tangent function actually cancel things out, and thus we're left with the t equals inverse tangent of 13 over 30. It's at this point where I need to employ the use of my calculator. So I say up we come, and then to be able to access the inverse tangent, what I need to do is I locate shift on my calculator, I click it once, then I go over here to tan, and thus I get the inverse tan. Putting in the ratio, and then I press execute. This is going to tell me that the angle of interest is in fact 23.43 degrees, and that was to 2 decimal places. And thus we're able to calculate the unknown quantity t. Alright, moving on to the next triangle. We have two known sides and two unknown angles. So we have two choices here. We can either make f our angle of interest, or we can make h our angle of interest. For the first one, I will make f our angle of interest theta. Consequently, this guy over here is going to be our hypotenuse, and this guy over here is going to be our adjacent. Listing the values. Alright, now next step, we're going to solve for f. We have the adjacent and the hypotenuse, so that means that we're going to use the cosine. Subbing in the values. Now we take the arc cosine, or we take the inverse cosine, whichever way you want to call it. Next step is we need to employ the use of our calculator. So up we come. This will give us an angle of 70.53 degrees. And of course that's to 2 decimal places. Okay, so this is f. Now for h, we've got two ways in which we can find this. Either we can go through the same process and use one of the inverse trig functions, or we can simply subtract f and 90 degrees from 180, which will reveal to us the value of h. However, because this is a video demonstrating how we calculate unknown angles within a triangle, we're actually going to use the trigonometric way. So we're going to call this guy now theta. Our hypotenuse is the same, but this quantity over here becomes the opposite now. So putting that down. Alright, working underneath. Say for h. and we're working with sine. And thus we come to the conclusion that the quantity for h is 19.47 degrees. Now, verifying that these calculations are correct, what we should find is that if we add f, h and 90 together, we should get 180 degrees. And thus we find we get exactly 180 degrees, therefore proving that f is 70.53 and h is 19.47. So in conclusion, what we had a look at in this video was how we can calculate unknown angles within right angled triangles when we're given two side lengths.